Welcome students. In this video we are going to see the next material property, that is Young's modulus. Young's modulus. So dear students, based upon elasticity, the engineering materials can be classified or having the two types. They are linear elastic materials, and non-linear elastic materials. So if we see it in the comparative fashion, so linear elastic materials, they obeys which law? The Hooke's law. कहाँ तक? up to proportionality limit. That is, up to proportionality limit, stress is directly proportional to the strain. We know it, isn't it? And if we look at this curve, the curve is how it looks like. The curve is straight line. Up to the proportionality limit, isn't it? Yes. So if you have this stress strain curve here, so you know it very well. So if this is the proportionality limit, then it is the elastic limit. Of course, this is stress versus strain graph or curve, and here is the fracture point, and this is the maximum stress in the stress strain curve, that is the ultimate strength, isn't it? So up to this proportionality limit, you can see here the curve is a straight line, it is a linear, isn't it? So here the curve is straight line up to the proportionality limit, and we get here the modulus of elasticity is what? The modulus of elasticity is nothing but what here in this linearly elastic material is the slope of the stress and strain up to proportionality limit, isn't it? So if I want to know the modulus of elasticity E, so it is nothing but what? This is sigma, this is E. So here, as this stress is proportional to strain up to proportionality limit, stress is proportional to the strain. So if I remove this proportionality constant, this stress is equal to E, capital E into small e, where capital is what? Our modulus of elasticity or Young's modulus, isn't it? So Young's modulus, we can get it as the stress divided by strain, which is nothing but, see, the slope of this line up to proportionality limit. So generally, see, if you look at the materials, example of this linearly elastic material, we can have all the steels are generally having this linear elastic or they are falling in the linear elastic material. But see here, if we look at these non-linear elastic materials, so the very first thing is that they are not obeying the Hooke's law. They are not obeying the Hooke's law, isn't it? Second thing, the curve is not linear. The curve is not linear, isn't it? So if we look this non-linear elastic materials, so say the curve may be like this. So this is the stress versus strain. Now in such a curve, if you want to find out the value of the Young's modulus or modulus of elasticity, so there are two techniques, you know it very well. So one thing is that we can have the tangent method. For the calculation of the Young's modulus, we are having the tangent method. So on this curved line, wherever you want to find out the modulus of elasticity E, you just draw the tangent to that point, and the slope of this line, this tangent, that is sigma upon E, is nothing but your value of modulus of elasticity, that is E is equal to sigma upon E. Or the another method you are having, that is the secant method, isn't it? Secant method. So in secant method, what we are going to do? So if this is the curve for the stress strain diagram, so any point if you want to measure the modulus of elasticity, from that point you can join to the origin, and you take the slope of that line, that is sigma upon E, you will get the modulus of elasticity here with the secant method. Any point where you want to measure this Young's modulus, find out the value of Young's modulus, you attach that point to the origin, isn't it? You will get the Young's modulus. So these are the two techniques for this non-linear curves to find out the modulus of elasticity. So dear students, if you look at the examples of this non-linear elastic materials, so which are they? So in this category we are having, say, polymers, cast irons, then the ceramics, then some rubbers, etc. Isn't it? So these are the examples of the non-elastic material, non-linear elastic materials. So in this video we have seen the Young's modulus, and from that, based upon this elasticity, we are having the two types of material, linearly elastic material and non-linearly elastic material, and for those material, how to get the value of Young's modulus capital E. Thank you so much.